Okay, the next concept of complex numbers to review is called the complex conjugate. And basically, if we have a real or a complex number a plus bi, then the complex conjugate, sometimes abbreviated z with a line over it, is simply a minus bi. And how do we use that? Well, actually, let's take a note that whenever we multiply a number, a plus bi, times its conjugate, a minus bi. All right, let's see what happens. So here's our, again, I'm going to do my squares. So I got a plus bi here and a minus bi here. So I get an ab. Actually, no, it's not ab. It's a times a, so that's an a squared. And here I get an a times b times I, and here I get a negative a times b times I, and a nice thing happens, those terms just cancel one another out. And then in here I get the opposite of b squared I squared. Now let's look at that. The opposite of b squared I squared is the opposite of b squared times the square root of negative 1 squared, which is really the opposite of b squared times a negative 1. Those two negatives cancel out, and we're simply left with b squared. So back up to that original problem, what is a number times its complex conjugate? It's simply a squared plus b squared with no imaginary part. This is a real number. So how are we going to use that? We could have, let's go back to a fraction. So what if I had a number like 2 over 3 minus I? Just like we don't like irrational numbers in the denominator, we don't like imaginary numbers in the denominator. So the way I get rid of that is I multiply by its complex conjugate. 3 plus I can't just multiply the denominator, I got to multiply the numerator by the same thing. So I'll take care of the numerator, and it's 2 times 3, which is 6, and 2 times I, which is 6 plus 2I. And now the denominator, I'll do the math. Here, 3 minus I, 3 plus I, so that's a 9, minus 3I, positive 3I. Those go away. And here I get a minus I squared, which is the opposite of a negative 1, which equals 1. So 9 plus 1, that's 10. All right, now we really want to split this up. We really want to split it up into a real part plus an imaginary part. So I'm going to rewrite this as 6 over 10 plus 2I over 10. Now it becomes obvious that I can simplify the fractions. So this is now 3/5, and 2/10 is 1/5 I. That's my answer. One more example. Let's say we were looking at 5 plus I over 2 minus 3I. We don't like that imaginary number in the denominator, so I'm going to multiply by the complex conjugate, which is 2 plus 3I, numerator and denominator. So the numerator is now 5 plus I, 2 plus 3I, so 10, 2I, 15I, and 3I squared, or a negative 3. So this becomes 10 plus negative 3, which is 7, plus 15I and 2I, 17I. So I know that's my numerator, 7 plus 17I. And then my denominator, well, I mean, I'll do it. I could just jump to the end, but I'm just going to go ahead and walk through it again. So 2 times 2 is 4. 2 times negative 3I is negative 6I. 2 times positive 3I is 6I. Those two terms go away. Negative 3I times positive 3I is a negative 9I squared, but I squared is negative 1, so that becomes 9. And now I know that I have 4 plus 9 or 13. I just want to break this into a real part, which is 7/13 plus an imaginary part, which is 17/13 I.